Lewis wants to try doing a collimated projector stack to double our brightness. I don't have a lot of hopes that this will work out, but I appreciate Lewis's initiative. Um, so here's what I'm going to talk about. What I'm going to talk about is thermal printers. Why am I going to talk about thermal printers? Well, there's two reasons. Number one is that I wouldn't say it's interesting, but I think it's interesting. So that's a good enough reason for me to talk about it. And number two, I honestly have too many. This isn't even quite all of them. I need to like thin the herd. And all of these are my special babies, and I love all of them equally. So I feel like if I have to part with some, then I should at least like tell people their lovely life stories first. The other reason to talk about thermal printers is I feel like people are weirdly into thermal printers. Like I thought it was kind of just me, but like me and Lewis have been going to this little, maybe I should just advertise it to you all. There's a guy in the downtown area who's trying to start like an Albuquerque art tech scene meetup. And so me and Lewis have gone to that a couple times. And there's always at least one person there who's like, thermal printer, I'm doing stuff on a thermal. People get excited about them. I don't totally know why people get so excited about them, but I have a few theories. One of them, I would say, I think this will be our best. I did not prepare demonstrations, and I don't know that I even have all the right cables to connect these right now. So we're just going to kind of go with, I like that I can't remember where the power switch is on this. I'll tell you what I use this for. Usually it's always on. But I think this is why people tend to love them, because they're quite fast. And if I remember, there we go. This is our test sequence. This does about 3 inches per minute, or sorry, 3 inches per second. This is the fastest of all of these, but thermal printers do tend to be pretty quick compared to other types of printers that we are familiar with. That makes them popular for applications where speed matters, and I also think it just makes them a lot of fun. I think another thing that's fun about thermal printers is that they're often used with continuous media, which a lot of, like, it's funny because it used to be that all printers really use continuous media, but nowadays we almost entirely use sheet-fed printers for our like computer printing. So, you know, the stuff that uses continuous media is fun. If I was more organized, I would have brought some examples. When I first got this printer specifically, wrote a piece of software where, this was like a dumb nerd project, but I wrote this piece of software where I could put in a flight plan in the like really condensed like ForeFlight format, and then it would print the charts, but like oriented, right? And so I had this idea that you could like tape them together on the wall, and I don't know, it was fun. It was fun to have these big log printouts of like 4-mile wide linear sections of aviation charts. So that's a little bit about why thermal printers are maybe fun and interesting. Now let's talk about what thermal printers are, which maybe would have been where normal people would have started this talk, but we're looping around to it later. So a thermal printer is a printer that prints with heat, pretty much like the name suggests. I think what a lot of people are maybe not as aware of is that I'm developing in my head right now a taxonomy of thermal printers. There are 2 major types of thermal printers, and then you can kind of subdivide them into other types. And those 2 major types are direct and transfer. So let's look at this lineup of printers that I have. Well, okay, let's organize things differently. So this is an Epson. We're going to talk about that later. All of these are Zebras. Zebra is not like a company that a lot of consumers would probably be familiar with, but they were one of the earlier companies involved in barcode technology, thus the name of the company. They held a bunch of patents on barcode symbologies back in the day, so you had to deal with them. That got them really established as one of the bigger manufacturers in like warehouse and logistics equipment. And so thermal printers are like one of the areas where they're still one of the biggest players, specifically in the warehouse and logistics world. We'll talk about the Epson situation in a bit. So this one is obviously weird. We'll talk about this in a minute. But if we look at these 3, let's see, we've got a Zebra S4M, we've got a GK420T, and a ZP450. Which of these 3 printers, if you had to choose 2 of them that are extremely similar, which two would you identify? Okay, yeah, so this is kind of like, this is a trick question, right? These two printers are essentially identical. We'll talk about the ways in which they are different, but if you look at the spec sheet for these two printers, there's basically no differences between them. These two are completely different. So let's talk about how they're completely different. This is a ZP450, and applications are worth talking about. So if we pop this open and pull out our roll, what I have in here right now will probably look familiar. These are 4x6. 4x6 direct labels, and these are now the universal format of choice for shipping labels. This printer, the Zebra ZP450, I bought in a bankruptcy auction from a Rio Rancho homeschool curriculum company. I kind of wish I'd bought more stuff from them because, oh my God, there was an Epson digital press that I think went for $300. I also got a phone system from them. I think just the fact that it was on what I'll call the ass end of Rio Rancho, where our friends live, meant that a lot of people didn't want to go out to that auction because I was kind of amazed some of the printing equipment, how cheap. I just don't have space for a 200 square foot printer, but I kind of wish I did. So yeah, these are usually used for shipping labels, and this model, the ZP450, this is kind of a fun one. The deal with this particular model is that if you have a UPS account and you ship enough, your account exec will eventually offer you one of these for free. So the funny thing about the ZP450 is that it is ostensibly software locked to only work for UPS. The way that they did that was just by changing the USB device IDs. So if you're on Windows and you're willing to futz around with your driver, the .ini files with the drivers, you can get drivers for other Zebra models to load for this, and it works fine. If you are on Linux like I am, you will never even know because whoever did the PPDs for cups just put the IDs for this in with the other ones. But that's a common application for this type of printer is shipping labels. Probably the most common thing you see them for. This is a direct printer. So as far as what matters, we have labels and we stick them in here and we kind of get them fed the right way, and then we close it and we are done. It helps if it's vaguely straight, although it's not all that important. And if I hold this button for a little while, then it will do this routine, which is kind of fun. And what it just finished doing is media calibration. So I mentioned these are often used with continuous media, right? Well, look at this. This is an example of a continuous media printer. But they're also often used in label applications, which are non-continuous media, and that means that registration matters. We need to start the top of the label at the top of the label on the roll, or everything goes wrong. So how do we do that? Printing is a beautiful industry, which means that there's 8 different ways that we do it, and everything is different. And so the solution is that everyone has tried to make everything support every method, and it's very confusing. So look at these labels. These are cheap. When I originally bought this, it had a roll in it of the genuine UPS stock they'd gotten for free, which was nice because it had a nice little blue UPS logo printed in the corner of each one. But I just got these. These were the cheapest option on Amazon for 4x6 direct thermal labels. And if you look at these, you'll notice a few things. Number one, the way labels work, right? We have sticker, and then we have this backing. This backing is called a web. That's just the industry term, is it's the web. So if you look at documentation, you'll see that. You'll notice if you look at the web between the labels, there's a little hole. And you'll notice if you look at the back of the web, it's got these black bars that are printed on it at regular intervals. This printer inside of it, right there, has an LED, and it emits light, which is detected through a hole up here. And when it runs, when it does media calibration, it advances the label, and what it's actually looking for is the gap. So it's looking for the difference in transmissivity between the label on top of the web and just the web. And by doing that, it determines how long the labels are, and it determines the registration, where the top of each label is. So then you're like, well, why'd I just tell you about the hole in the black box? What's all this bullshit for? Because there are other types of printers. There are many ways to do this registration. One common method is gap on the side of the web. One common method is black bars at regular intervals. You know how long the label is. You count the black bars to figure out where you're at. This particular printer and many newer thermal printers doesn't bother with any of that. With newer technology, the thing where it just looks for the gap, where it can see the web, is reliable enough that a lot of labels don't even come with these features anymore. These just happen to, and this printer doesn't even support them. These two do. But you know, there's a lot of ways that gets done. The great thing is you don't have to worry about it. Most modern thermal printers auto-calibrate media. So if you just put media in it and then print and it's not happy with knowing the size and registration, then it'll just spew out a few labels until it's measured it and it thinks things are fine, and then it'll print your job. Which is annoying if you're like me and you're stingy about like, but my valuable labels, these cost like 15 cents a piece. But you know, it's not that big of a deal. So I said, these are totally different. How are these totally different? Well, let's open up our 450 and let's open up our 420T. And you will notice that the interior of the 420T is more complicated. So let's talk about how thermal printers work. Thermal printers work because thermal labels are thermally reactive. Do I have, if I just like rub this with my phone case maybe? Yeah, I can get it hot enough by friction to get it to start changing colors. All these do. It's kind of crazy simple if you think about it. If you look at this bar, this is a linear row of pixel-like heating elements. And as this advances the label, it heats up those heating elements to get the face of the label hot, which causes it to darken. And that is all that is going on with a direct thermal printer. One of the great things about them is also that they are very simple. And that makes them reliable. It also kind of makes them cheap, although it's a specialized enough industry that name brand ones can be quite expensive, but generic ones are generally very cheap. This is cool because the supplies are so minimal. Like if it's got labels in it, it'll work. So probably most thermal printers that you'll run into in the real world, like in your daily life, are direct thermal printers that rely on a thermally reactive media in order to operate. This also has downsides. The print quality is it's never super good usually on direct thermal printers, but the bigger problem is durability. Just like a property of the way that these are manufactured. How am I doing on time? I have like 1 minute left, right? No, I think it should be longer than that. Yeah, I got a whole thing. We're only halfway through. I get to keep going. So just a trait of the chemistry behind these is that isopropyl alcohol, a lot of direct thermal media will turn black if it's exposed to isopropyl alcohol. It's funny that I even know that off the top of my head, but I do that by accident, like surprisingly often. But then the other thing is heat. Like a lot of, you might have seen this before. Sometimes if you leave a retail receipt in the sun, it'll darken. And they also fade over time. Basically, all direct thermal media, if you wait like 3 months, will be pretty much blank. None of these are very thermally stable. That's kind of a problem with receipts. Some places know about that. Like I started thinking about this. Is this when my whole passion for thermal printers started? I thought about this years ago because I just like made kind of a big purchase, and the clerk who I guess had thought about this took the receipt and then he photocopied it and he gave me the photocopy. And he said like, oh, these always like fade after a while. And you know, this is like a thing with like a multi-year warranty, right? So it's nice to have the photocopy. So something to be aware of, and it is a reason that if you're keeping a receipt for something that you know has a long warranty, you probably want to like scan it or take a photo of it or copy it so that it's not just on the direct thermal media. Yeah, well, let's talk about transfer. So for direct, you can't really get around that. More expensive media tends to be better. There's a couple different kinds of direct media. So if you spend more on like the polypropylene media rather than paper, that tends to last longer, but you never really get like a good result. So this relies on thermally reactive media that changes color. But there are other kinds. Somewhere I have a roll of media that looks basically identical to this, but I've Sharpied Xfer on the side to remind myself that it is not thermally reactive. You can buy rolls of 4x6 labels that do not change color when exposed to heat. So how do you deal with those? You use a thermal transfer printer. So the big difference with this printer is that up at the top we have a ribbon handler, and we have something that's called a ribbon. So this ribbon is coated in, I believe it is actually a plastic, and I believe it also has a lot of BPA in it, and you're really not supposed to get it on your hands. So just, keep that in mind. True of direct labels as well, actually. If you have a job where you handle these all the time, you might want to consider wearing gloves. They basically are all BPA coated. So this ribbon runs under the heating element, which you can't even really see because it's behind it. And then when this operates, it presses the ribbon against the media, and then it heats the back of the ribbon, which causes that coating to melt and transfer onto the media. That's why this is called a thermal transfer printer. It's a little more conceptually like how our photo-optical or laser or LED printers work. A cool thing about transfer printers is that pretty much all thermal transfer printers will also function completely fine with direct media. You just remove the ribbon. They're all designed so that they're pushing the heating element against the back of the ribbon. So if there's no ribbon, they just push it against the media. A lot of them, you do have to go change a setting or they'll refuse to run because they think they're out of ribbon. But if you configure them that I'm going to use direct media, then they work fine. So transfer printers are in a way more flexible, but they do tend to be more expensive. Big upside to transfer printers is that you get a huge world of possibilities with them. There's many different types of media. There are many different types of ribbon available for them. And you can get much, much better durability from transfer printers. There's a surprising number of things you see out in the real world that probably came off of thermal transfer printers that you might not realize. A big example in my mind, because I've always wanted one of these machines, I've just never gotten them for cheap. When you look in buildings and there's exposed piping and they've got hot water with the arrows on it to label all of the pipes, those are very often produced on site with a thermal transfer printer. Brady is a company that makes, they also make this kind of equipment, but they're more in the construction and industrial world. Brady makes an appliance where you just push hot water, arrows to the left, and it comes out so that you don't have to try to have a stock of all the right ones. Those are done using a resin ribbon onto a polypropylene label because that is very durable. Those hold up really well even against abrasion. The downside is that the resin ribbon is pretty expensive. So the ribbon I have in this right now is a wax ribbon, which is cheaper and not as durable. They tend to rub off. Okay, so now let's address an interesting question. I said these are basically identical. So what's up with them looking totally different? These are largely the same printer, but they are made for different markets. So this is your desktop form factor printer. A lot of people who use these are using them for applications that are a little more office-y. Things like shipping labels, labels for medical, sample specimen. Where else do you see these a lot? Hospital wristbands, that's a fun kind of thermal media. Well, I'm thinking about medical applications and kind of general purpose labeling. Something to observe about these printers is that both of them have a 4-inch wide print path. So I can run 4x6 media in these. They will also print on much thinner media. So you've got a lot of flexibility. If you're getting a thermal printer, I would say get as wide as you can because you can generally print on narrower media as well. I'll try to remember to mention an important exception there. This is not really manufactured for the desktop application. This is manufactured for use in primarily in warehouses and logistics sorting facilities. So almost the exact same specs, which is media up to 4 inches wide, I think 1.5 inches per second on these two printers, and 203 DPI resolution, which is a slightly weird number, but for whatever reason is just the convention for most thermal printers. I don't know how we ended up with the 203. Big difference between these two. Well, first big difference is this has more of a local operator interface. You can change settings on here. Changing the local settings on this printer is kind of annoying and painful. Second, this has a built-in network interface. That's a factory option, but when I see these, they virtually always have it. So it's got a network adapter on the back. That's convenient. This also has USB, which is nice. Some of these are like this one. No? well, like this one, are older and only have serial and parallel. Another big difference between these two is that this one opens like this, and this one opens like this. And in like a, in kind of your warehouse application, number one, this is just easier to deal with. Number two, you can fit much bigger rolls in this. So, media, you'll notice that I have rolls. Don't look too close at this. This is a mess. But most of the time, we tend to use rolls, but we actually don't have to. If you look at this, it's really obvious there's a hole in the back. These actually have one too. They're intentionally designed so that there's a gap at the back of the hinge. The reason for that is that you can also run flat or Z-fold media through these. And the way you usually do that is you put your stack of media just behind the printer and it pulls it in the back when it runs. Z-fold media, if you're not like familiar, is like, right? It's like a stack, but they're folded at the end. Am I describing that coherently? It's like this, right? And then it just gets pulled in off the stack. Often used for more rigid media that doesn't roll up very well. Airline tickets are direct thermal, but they come off a Z-fold stack instead of off of a roll. Conference badges. I don't know if you've gone to a conference where they're doing on-demand badge printing, but you've probably seen that. I wanted to like rig that up for ZeaCon, and I was gonna have like an iPad, and it was gonna have a registration sign, and it was gonna ask you like 100 personal questions, and then it was gonna like print you a badge that didn't even have your name on it. The reason I didn't do that is because those rigid conference badge, those are like weirdly expensive. I was digging all over, and even at like MOQs of 2,000, they were still like $3 a piece. So that's why conference registration costs so much these days. When you spend like $1,400, they're getting that media for your badge.
I'm like, just use the 4x6 label.
Yeah. I should have just done it anyway and just slap it on your chest. And maybe it's also good for postage. So this is kind of nice because how much it opens up lets us kind of demonstrate all the parts better. So this is the actual print head is on the top of this. This is the supply roll for ribbon. I just don't have any ribbon in this at the moment. But it would run basically down under this and then up onto this. This is the take-up roll for ribbon. So it runs that when it prints so that the ribbon stays taut. And then this mess is the media. So this thing on the back is kind of a flexible media hanger so that you can put a lot of different types of media into this printer. And then your media also just runs out through the front here. There's a little guide to try to keep it in position. You close that down, and now you're printing is the idea with this. So same mechanism, same specs as this printer. It's just kind of bigger. This is also rated for a higher duty cycle if you look at the spec sheets. So I assume it's probably got like a beefier power supply and nicer motors in it. But basically the exact same thing, just intended for more heavy duty applications.
So question, if it's intended for more heavy duty, like where's the spindle for the roll?
Yeah.
Because it seems like hanging out on the floor of the unit is a bad
It is indeed, this is where the roll is supposed to go. This just doesn't have a big enough core. There's another, and this is like the kind of annoying inane thing, but this printer expects a 1/2-inch core for both media and ribbon. This expects a 1-inch core for both media and ribbon, which is just annoying. I think both of these are 1.5 IPS, whereas this does 3, and this might also do 3. Transfer printers do tend to be slower. I don't know that they fundamentally need to be that way versus just that they tend to sell to less speed-sensitive markets, but that does tend to be the trend.
What is the upper limit on speed?
I don't personally know of thermal printers faster than this one, which is 3 IPS, but I wouldn't be surprised if they exist. This is sort of interesting. This is essentially the same as this. It is a direct thermal printer. It's a little bit slower and it's smaller. This only takes 3-inch media, 3-inch wide media, whereas this one takes 4-inch wide media. The thing about this is that it's intended to be used this way. So there's like 2 big applications for these that I know of. I always mention Schwann's. There are home delivery services where the drivers wear one of these to print receipts. And then I have also seen, I think it's FedEx has some drivers that only pick up packages. And I've also seen them use these to give people receipts on the more expensive services when they pick them up. Parking tickets. Yes, and in fact, you'll notice this says property of Inverse Medical, because that's who I got it from. I don't think they went bankrupt. I think they just didn't need it anymore. But this has labels in it. This was in a like a field COVID testing kit, so it would have been used to label the the samples. So, and that's another application for these portables. Widths. So two things I want to mention real quick. Number one, widths. 4 inches is the widest that you typically find label printers. However, it is not very hard to buy 8.5-inch wide thermal printers that can thus print full letter-sized pages, usually off a continuous roll, but they often have a tear bar or a power cutter so that you can get nice 8.5 by 11 pages out of them. That used to be very common for fax machines. I actually should have I have a fax machine that works that way. It's rare to see fax machines these days that use the thermal media because they're mostly built into inkjet printers now. So my joke about the 8.5 by 11 thermal printouts is you probably don't want to get one because by far the largest application I know for those is traffic citations. New Mexico State Police, you get a speeding ticket, that's coming off a thermal printer that they have taped to their dashboard, but it is 8.5 by 11 and they cut it at 11 inches. So it's a nice normal sheet of paper. The reason you can tell is because it curls. You can tell that the media came off of a roll. And also now you owe the state $66. So that was the first thing. Second thing I want to talk about a little bit is control. But before we do that, because I am going to run out of time, I'm going to cheat. No one saw that. I just want to briefly tell you, I didn't want to talk about this as much because we've all seen these, right? This is an Epson receipt printer. This is a whole family of models. This specifically is a TM-T88-4. Epson has made the TM-T88 with very few changes since 1988 or something like that. Almost every grocery store is running their receipts on these. Yes, Ancients?
There's one of those that has a Raspberry Pi on the inside.
Oh, yeah. I have a couple of these. The two that I have are different generations, so they have different interfaces, which is interesting. This one is old enough that it's only has a serial interface on it, but you can change out these modules if you want. Not very different from the others. It's a slightly weird width that, for whatever reason, is conventional for receipt tape. It's 2.33 inches, I think.
What is that in?
I don't know. These do not these do not narrower media. They don't have a way to center it, so you have to use the width that they were intended for. But they're fast, they're fairly cheap, they're easy to come by. They're direct thermal printers. Cool thing about this has a power cutter. None of the others here have a power cutter. They all have a tear bar or a peeler, which it's kind of fiddly, so I probably won't show it to you unless you really... And did I just break this again? This stupid part, I have spares because they break so easy. It's like a crazy design defect. I'll show you what I mean if you want about how that broke, and you will agree that it's wild that they thought that was a good idea. So this has a power cutter that you can see if you open this door. There's a little motor that spins a little thing that pushes a blade to cut the receipt, which is cool. None of the others have that. They expect you to either just tear it or to use the peeler. And the way the peeler works is you wrap the web around another roller so that when it prints, it pulls the web away. That's convenient if you're just sitting there and you're going to put the label straight onto something. So, okay, last thing I'm going to talk about, and then I'll shut up, I swear, is we're going to talk briefly about control languages. Basically, all of these printers, it might even surprise you, you can use as a totally normal printer. In fact, if you look at the ribbon on this, oh, this is a security thing. Hey, security implication. These ribbons, you can roll the ribbon back and then read everything this printer has ever printed on this ribbon. And I have come across some interesting things that way. So, but if you look at this ribbon, it's got the remainders. You probably can't see it, but it's got the remainders of a cups test page on it right now because I was just testing something. So basically all of these printers you can use as like plain old printers. Most of them have conventional Windows print drivers. Cups supports the control language that these take. So you can just like print your Word documents on a narrow strip of paper if you really want to. But if you truly want to have some thermal printer fun, then you probably want to use the native control language of the printer. For all Zebra printers, and really most label printers, that is ZPL, which is Zebra Programming Language. You can guess who came up with that. For most receipt printers, and obviously those made by Epson, that is ESCPOS, which is the Epson Sony control language for point of sale, I think is what that stands for. Basically, what both of those amount to is if you send these printers ASCII text, they will put it on the media. And it's kind of that simple. If instead of ASCII text, in the case of ZPL, you send uptick or $ZP and then a confusing sequence of letters, those are control codes, which you can use to command these printers to do a variety of things. That can include some formatting. So if you look at your retail receipt, these can do text. They can do text in a small font. They can do text in the big font that is double height or double width or both. Those are all native capabilities you just turn on with control characters. So a lot of retail receipts have the name of the store at the top in double height text because it's just easy to do. But if you're a little bit nerdier, what you might find more interesting is that all of these printers, more the Zebras than the Epsons, but all of them can generate barcodes on board. So that's pretty useful too. You can send escape codes in which you indicate a symbology and a positioning and a payload, and they will produce the barcode internally. And that is nice because they do that very fast. Whereas you will discover, in general, sending raster data to printers is slow and you don't want to do it, and that's a whole discussion we can have later. But especially you don't want to send raster data to these, meaning pictures, because they are not built for it. They have very slow processors, and they will take a very long time to decode a JPEG. They all offer to do it. They will do it. You will wait. It'll print like a centimeter, and then it'll sit there, and then it'll print another centimeter. It'll sit there because it's doing the rasterizing on the image. But you might wonder, lots of stores that you go to, they put the logo of the store on the receipt. So if these things are so bad, this is the last thing I'm going to say, and then I'm going to shut up because I was out of time like a few minutes ago, I think. The way they do that, this is kind of fun, is that all of these printers have some writable flash storage. They, especially the Zebras, run a very weird operating system that I swear is like pretending that it's a VMS. So it's a very weird like path syntax, but you can actually take your Walmart logo as a 1-bit bitmap and then write it to the flash storage on these printers. And then you can send them a control code that just tells them print the bitmap data from this address to this address in memory. And that's how retailers generally handle printing logos and graphics on receipts, is they preload them into the printer's memory in uncompressed form and then just tell the printers to read them out. That is very fast. Okay, I think that's the end of my talk. Are there any questions?